Hello, in this screencast we're going to look at trending with Persyst 15 for an intracranial recording, and we're going to extend the frequency range of those trends up to above the default 45 Hertz to look at higher frequencies. My name is Michael Guest, VP of Research and Clinical Applications for Persyst. Let's go ahead and get started. I'm going to go ahead and launch Persyst 15. We're going to make some setting changes after we open a file to set up for this. One of them is we want to go to Preferences and General Preferences and click the Database tab. And here I've set a imaging directory root folder, just as my C/PIW. But in practice, this folder will be a network folder that is accessible from other review stations, so that when you create an intracranial montage for an EEG, that one is saved and it's linked to that particular patient recording. So you can go to another review station, open it up in Persyst, and have those montages available and not have to recreate them. The other thing I'm going to do is set up my database. And again, I've got the example recording on the local hard drive. In practice, this would be, again, set to a UNC path, which you can tell by it has a / in front of the name rather than a map network drive. But this one happens to be in my local computer, so I'm just going to go to this PC, to my C drive, and to the EEG folder that I have set. And I've already converted this to Persyst layout format. And that was, again, part of the de-identifying the recording and putting in some simulated patient information. That's what links the intracranial recording. So I'm going to select OK here. And it reminds me that OEM format is normally what you want to use, which is true. Having done all that, I'm going to select the open button, and here we have our example recording. Now, what I noticed right off the bat is that we have some channels here that are showing 1020 labels. Those are not 1020, they're not scalp recording. Sometimes you'll have stereo EEG with scalp. Does not appear to be the case here. And so what I'm going to do is, when I'm configuring the recording, I need to do two things if it detects what appears to be a number of scalp channels. First is I'm just going to click on this patient tab here, and I can see here that it says that it's an 81 channel recording, but it is detecting it as a 1020. It's sampled at 2 kilohertz, but the resample rate for the purpose of calculating artifact reduction on scalp EEG is below 300 hertz. Now we want to look at high frequency, and so what I'm going to do is turn off that downsampling. Normally, in intracranial recording, if it doesn't detect 1020 labels in the hardware, it'll assume that it is a intracranial and automatically toggle that off. I'm going to go ahead and select Preferences, Trend Preferences, and we're going to go to the filter values. This isn't tied to a particular trend template. I'm just going to turn that off right here. Select OK. I'm going to close and then relaunch Persyst, so that now, when I open that record from that Persyst database, and I click the patient tab, I no longer see that resample. It's just the native sampling rate of 2000 hertz. Okay, so that was step one. Step two is we'll go ahead and create an intracranial montage. I've got ones that I already created previously for this, and so what I'm going to do is delete those, and we'll go back through the process again. And to do that, and again, it's detected that it has some scalp recordings. I'm going to say, or scalp channels. I'll say OK to that. I'm going to delete the existing implant. Once I open it, not to modify it, I'm going to select delete, and it goes ahead and deletes that set of montages. So when I click the drop down here, I no longer see them. You don't have to do this each time, but we're going to reanalyze this recording with fresh trend settings that look at higher frequencies. So next step is I'm just going to create that intracranial montage. And that's the current name. I'm just going to change. Normally it has the name of the patient and the date. Just to shorten this up a little bit, I'm just going to call this IC example. And I'm going to go ahead and select the implant settings. Now, some of these settings really apply to when you're looking at the Persyst imaging workflow to localize the intracranial electrodes and set those in respect to a image CT and MRI. And you can automatically or semi-automatically tag the electrodes so that you can see them and relate them to what you're seeing in the EEG. We're not going to be going through the imaging workflow, but some of these settings do relate to that. For instance, these are likely depth electrodes. and they would have smaller electrode spacing. Typically, these are the things that you'd set up the defaults for that purpose of going into the imaging workflow and making your image and electrode localization set up there. But we're not doing that here. I'm just setting that. But importantly, for the purpose of creating trends, if we know these are depths, then we want to use this percent of channels per trend as opposed to the number of channels per trend. So you use this typically with grids or strips. But for depth electrodes, we typically want to break up the trends and have one trend that's the electrodes closer to the surface, and then they have the other half of those electrodes in a separate trend that are deeper structures. So we're going to go ahead and default this to percent of channels per trend. And we're going to deselect this because it does not include scalp and intracranial. It's just intracranial. Now there's non-EEG channels. This is the default list. If you had other channels that were included in the recording that you did not want to be included in the intracranial trends, then we would go ahead and identify those here. And we'll go ahead and select OK. And it'll refresh the screen. Now looking at this, I don't see any ones that are obviously not recorded. Sometimes you'll see records where, depending on the default channel label, you may see a bunch of channels labeled with a C prefix that are designated as unused. But in this case, these are used. This is a 1x10 array. But any unused ones, we'd select the trash can button here to delete that hardware group. But all these hardware groups appear to be in use. So let's go ahead and select Create Montages. Now in Persyst 15, we get the option to create trends as well. Now, when we're calculating FFT spectrograms, one of the things to keep in mind is all those FFT values are stored, and there's a limit to the results file size in this iteration of Persyst 15. That's up to about 4 gigabytes of stored FFT values. And so what it does is it calculates the estimated max recording duration that can be trended. And so with the default settings here, we could trend up to 56 hours. This recording is significantly shorter than that, but if you're recording long-term intracranial, usually those are in 24-hour stages. But if you did increase the max frequency so that it was storing additional frequency values, you may find that this value drops below 24 hours. And then you can configure the acquisition machine to record shorter stages so that the recording would roll over earlier and start writing a new Persyst FFT results file. And that would keep it within the range. So let's say you had a max duration of 15 hours. You might set your recording system to roll over every 12. This is offline processing. So really what we want to do is make sure that this value here, the max duration, is longer than the length of the recording. That's the only consideration there. Now, if we're looking at higher frequencies, we may want to set this, for instance, to 250 hertz. We'll just try that. And when I do that, we can see that the max recording duration here drops to 14 hours. Now, these do have a 1-second step. So it's calculating the FFT over 4 seconds and then moving it forward 1 second at a time, so they're overlapping. And if we wanted to decrease the results of our file size, if we didn't mind having 2-second resolution, we can set that, and then we can see this number doubled here. But let's go ahead and leave this at 1. And then I just click into another box and it updates that, because this will certainly carry the duration of the recording. It's less than 14 hours. So we're going to calculate up to 250 hertz. We're not going to add rhythmicity spectrograms. If you did that, those values are stored. Again, it would increase the size of that file, or add these other ones. Spike density trend really doesn't add any size to it, but we're not going to do spike detection in this particular recording. We're just going to create these FFT spectrograms. Let's calculate heart rate too. So we're going to have the channel for EKG selected for that, so we can calculate that trend. And we should be able to find that. I'm not seeing that here, but we do have that in the channel list. So it does say EEG to ref. Okay, so that is the ECG channel name. So we'll leave that as it is. We'll select OK, and it's going to drop this on the desktop. So we're going to move that file to the program data folder. And the reason for that is I'm just going to go ahead and close this. But before I do, we'll click this. We'll see that our montages have been created. And if we go here to the trend preferences, we can confirm again that our filter values, we have that downsample turned off. So what I'm going to do is close this. Just to simplify things, we're going to go ahead and go to this trend template. I'm going to go ahead and cut this, open up my File Explorer, go to my C drive. Now, if I don't see the program data folder, I could select View and Show Hidden Items, or I could just simply type program data here. But we're going to open this up. This is the standard place for Windows to have programs store their settings. And you can see other programs listed here. So that's the standard place for Windows 7, 10, and Windows 11. I'm going to click Persist. I'm just going to paste this file in here. And so now that trend setting is here, and I've got it along with my other trend templates. That makes it easy to switch between them in practice. So let's go ahead and we'll just minimize this. We could close it, but that's what I wanted to do. We could run it from the desktop, but as a good practice, it's good to go ahead and put in that program data folder for now. So let's open up Persist again, and let's create some trends and process some trends. So I'm going to go ahead and open this file. And when I go to the Preferences and Trend Preferences, I can select that trend template. That's that button here in the bottom left. It says it's been processed. I'm going to reapply that. I'm going to end up deleting the earlier trend template, but there's the one that we created. I just sorted it by date, and it shows up at the top of that list. Now, if I split the screen, I had already processed these. I'm going to delete those trends, that earlier processing run. And so now I've applied this. This includes our hardware groups, and I'm going to select Process. Now, while this processing, we see over here it goes 0 to 250 hertz. That's going to compress things a bit. It's hard to see certain changes when we're looking at a frequency range that large. Again, this standard size is 45 hertz to give us a little bit easier view inside of those. There's some things we can do to help with that, though. Underneath the FFT spectrogram selection, we have our individual hardware groups. And you can see here it says A1 through 6, and then A6 through 10. So it's actually, as we described, it's separating that one piece of hardware into two groups, where we have one that's closer to the surface, and the second set of electrodes, which is deeper structures, if that's how they're ordered in that case. And we can select any particular hardware group. And what we're going to be using for looking at high frequencies is the FFT-Z spectrograms. And we'll talk about that a little bit more as we go further. But what the FFT spectrograms do is they look at the EEG at each one of the frequencies by bin, and it calculates the amplitude by frequency. So we have FFT calculated by amplitude from 0 to 250 hertz. And we typically have much more amplitude in lower frequency ranges than we do in the very high frequency ranges. And so we can see changes at the lower frequency spectrum. Let me go ahead and just click on this trend display to move the cursor a bit. And I'm going to move it a bit back. So there's something happening here in the EEG, and it's sitting pretty far down here. The other thing is we can darken this a bit, change the gain, how many microvolts per step of that color scale. And as I move this down, those patterns become more visible in the trends. So pick a good value there, but we can see that this is showing up now. If we're using lower frequency ranges, that would show up probably even a little bit better. But we can also start looking at this by hardware group. And here's our first hardware group where we can see that change depicted there. Now, let's see if we can show this a little in a way that's a little different, where we can see the changes at the higher frequencies. Because again, we have much higher amplitude at these lower frequencies. So, and we're still processing the EEG, that's fine. Doesn't hurt it a bit. So I'm going to go ahead and select this. And what I want to do is use our Z spectrograms, our versus baseline spectrograms. They're called Z spectrograms now, but we're going to update that so it calls them versus baseline rather than Z-score spectrograms, because versus baseline, a little bit better description of that. let's go ahead and go to a place in the trend that is pretty stable, that we want to set as our baseline. And we can page through this and see that this range of EEG will be suitable for setting a baseline. And you can set baselines anywhere you like in the recording. What I'm going to go ahead and do is select the baselines button and then new baseline. And right now this has 180 seconds that is picked. We can make it a bit longer if we like. Typically 5 to 10 minutes is plenty for setting a baseline. So now I'm going to select add baseline. And you can do shorter ones. It just gives it more samples to calculate the empirical null. I'm just going to call this the first baseline. And select OK. So now the first baseline has been set. It'll take a moment for it to appear at the bottom of the screen there. Yep. And there's our baseline indicated by that pink bar at the bottom. And again, you can have multiple baselines. There's different options available from this menu, and those are described in the online help system. So let's go ahead and switch to our Z-score spectrograms. We'll do all channels. And now what it's doing is it's rendering this in Z-scores that are normalized throughout the frequency range. And increasing Z-scores are rendered in red, decreasing Z-scores from the baseline are rendered in green. Let's page forward and get to where we see that first seizure, and here it is. So there's that first seizure. And again, we're rendering these to 250 hertz. These are a bit compressed. We could hide the labels here. If we right-click, we can hide trend names, rather. And it gives us a little more room. But having those trend names is actually pretty handy. So I'm going to deselect that. But looking at this, we can see this increase in shading by hardware group shows up in this A1 to 6 bipolar set. And we also see some in this E1 to 4, channel E1 to E4, and BI means it's a bipolar arrangement there. So let's go ahead and look at this by group. So let's investigate the channel A1 to A6. So I'll just go here, Z-score spectrograms, and we'll pick that first set. And we can zoom in on this even further. I've selected the time range, go down to 5 minutes. And this is a rendering of Z-scores from 0 to 250 hertz. And we can see which channels that they appear to be most prominent in, or which pieces of hardware. Now, if we want to zoom in on the channels here at that particular hardware group, we can right-click here. We can select hardware group, and we can pick the A hardware group. So now we're just looking at those. So if we go back to select that montage again, they all reappear. So we can go through these by hardware group. Let's go back to all channels. And there was another one we wanted to look at. I think this group E1 to E4. So let's select that from this dropdown. So we'll go to the E1 to E4. And this is, again, trending 0 to 250 hertz. And we can see the range of frequencies here pretty well. It's normalized. Now, if we look at the standard FFT spectrograms for the E1 to E4 group, we again see in pretty fine detail the lower frequencies, and we could change the scaling of this to a little bit lower to see if we can see much more. We're already down at the minimum 0 to 1. And again, because those are so much lower amplitude at the higher frequencies, it's pretty faint. And we tend to exceed the dynamic range of the color bar at that setting. So typically with this, you want to set it so that you can see those finer details of the evolving rhythmic patterns here in these spectrograms. And if you want to see what's happening at the higher frequencies, that's where these spectrograms come in handy. And again, I'll select the E1 to 4, and we can see that rendered all the way up to 250 hertz pretty well. Now, once we've done that, let's have a look at the higher frequencies there. So let's start with our first group of interest. So we'll go back to this, and we'll look at that channel A1 to 6, because we see all this activity here. And I'm going to click back a little bit where I see that high frequency begin. And this one, I expect to see most of that showing up in channel 4. Let's go ahead and hide some of these electrodes. So I'm going to select hardware group, I'm going to pick group A. And I'm going to page into this, see if that looks like it is indeed an onset. But now I want to look at the high frequency component of that. So let's go ahead and select Tools and create high frequency display. And so we'll leave that channel name. Actually, I'm just going to call this MGHF to make it a little shorter label. Now I can look at any frequency ranges I want. I can change this once it's launched. I like to start with 50 to 150 and 7, because once this launches, now I can control the gain here, and I can either intersperse or overlap those channels. Now we're looking at 50 to 150 hertz of 5 microvolts. And this, well, let's scale it from 100. Let's reduce that to 50, because now we don't have as many channels to contend with. Oh, my notch filter should probably be set to 50 hertz. Depends on the area that this was recorded, so I could analyze the line noise. We don't really see a lot of line frequency here. But you can overlap them to save space or to see if they're phase locked, things like that. Let's go ahead and remove the overlap, though, and just page into this. And we're beginning to see this burst of high frequency. Let's change our time range from 10 seconds. Let's go to 4 seconds. And let's change our sensitivity here to 3. So here's our high frequency from 50 to 150. And I can page forward into this. And I'm beginning to see this high frequency activity, which corresponds with the Burger Band EEG changes. Let's go ahead and overlap these. If there was any question about if these are phase locked or not, we can page forward in this. And we're seeing them rendered over here on the right in z-scores, but we're also looking at the actual waveforms here on the left. And if I want to change the frequency range, let's say I want to go up to 300 hertz. Now this is showing low cut of 50 hertz, high cut of 300 hertz. There's not a lot of lower frequency causing an issue. So if I change this, I don't expect to see a lot of difference. So it's attenuating quite a bit. Well, why is that? Well, let's see what frequency these bursts are. And to do that, I can remove the overlap just to be a little bit more specific about what I'm going to measure. I go to Tools, and I'm going to select the Quick Stats tool, and I'm just going to drag a box around this and get the frequency, actually just about 70 hertz, 69.44 hertz. So even though I've opened up my high cut to 300 hertz, this is still showing up at a bit lower than that in the 70 hertz range. And again, we can page forward through this. The opacity, by the way, if I change that, let me go ahead and put the overlap back on. This allows you to fade in and out the high frequency on top of those waveforms if you're superimposing them. So once I've looked at this, as we're going into the seizure, I can go ahead and, let's say, look at a different set of channels. So let's go ahead and go back to all channels. And I'm going to go ahead and go back to my bipolar montage. So I'm showing everything. Let's use our z-score spectrograms. Now the other hardware group I wanted to look at is not just this A channels, but I'm seeing some of the show up here in the E1 through 4. So I've clicked early where I'm starting to see some of that show up here. Let's go ahead and zoom in on that particular set of hardware. So I've done that. And I want to get before that change happens. So I'll go back here and I'm going to look at just that set of hardware. So we're going to right click on a channel hardware group and I'm going to select the E hardware group. And as I page forward into this, let's see what happens. And let's go back a little bit. So I just clicked on the trend on the right to move that. I don't need this. You could open or close your comments. I'm just going to make our trends a little bigger by folding these back to tabs. Change our gain. And let's go ahead and create that high frequency display for these channels. So I'll go to Tools and we're going to create high frequency display. And again, I'm going to give this the same name that I had before, MGHF. I can overwrite the previous one. I'm going to leave these settings as they are, 50 to 300 hertz. I'm going to overlap that montage, or overwrite it. And I don't need overlap. I could, but again, I can display these separately, and I can page into this and see what happens with the high frequency content as I go into this recording, or go into that event. And sometimes you're looking for things like, are these high frequency patterns here, do they line up with something in the Burger band EEG? I can overlap them. I can change the time scale, zoom in a little bit more, and see if they correspond. So different things you can do. So this is really an exploration of the buttons, not really attempting to do an interpretation of the recording. Just wanted to show some of the features by selecting lots of different options within the software to give you an idea of the workflow and the navigation. And that is how we go about that process. And you can certainly use the Z-score spectrograms for hunting for other changes of interest in the recording. These again are showing up at the higher frequency ranges. So we could change this, and we could apply the high frequency display tool to get an idea of just what the high frequency is. If it's associated with a seizure or not. This looks like there's an evolving pattern there. Yep, certainly is. I can see it in the traces here that it's evolving. I can zoom in on that hardware group, and here we can see it painted out pretty nicely on that. So that's the whole process. Any questions, feel free to contact me. Again, this is Michael Guest, VP of Research and Clinical Applications for Persyst.